First, we're going to start with a graph of cosecant. Usually, when I give you a cosecant function, you will rewrite it as 1 over size x, right? Cosecant and size are reciprocal of one another. Now, this being said, that the vertical asymptote for this function, because secant is 1 over size x, and we learned that the vertical asymptote is when you set the denominator equal to 0, right? So you set size x equals 0. If you look at the unit circle, what value from 0 to 2 pi, what value of x will give the psi x equals 0? Remember, psi is y value. Where? Yeah, so let's start 0, right? From 0 to 2 pi. So it's 0, right? Psi 0 is, yeah, is 0. Where else the psi x is going to be 0? At pi, right? Size pi is 0. Also, if you go back to the original, so here is 0, and 2 pi is also give you 0. So there are 3 values, just between 0 and 2 pi. 0 pi, 2 pi will give you the height is 0, right? That's where you have the vertical asymptote. Of course, if you go one more surround, say you go 4 pi, but have 4 pi, then at 3 pi, you also have psi of 3 pi 0. 4 pi 0 is psi, 4 pi is also 0, and on, right? But or you can go backward. You can do backward. Instead of going clockwise, you do counterclockwise. So instead of 0 pi, I'm doing 0 negative pi, right? So negative pi here. Size of negative pi is also 0. Right? But for this problem, we only care about the period of 2 pi, right? Because the period of psi and cosine is 2 pi. So for that problem, cosecant of x, or another way of writing it is 1 over size x, has the vertical asymptote at x equals 0, x equals pi, and x equals 2 pi. Let me draw that vertical asymptote. So x equals 0 is the y-axis. X equals pi. That's the vertical asymptote. And x equals 2 pi. That's represent one period. Remember, the period of psi is 2 pi. Now, let me figure out how the cosecant graph corresponding to with its values. I want to consider, remember you consider the point around the vertical asymptote. You're going from left and then right. Remember that on your exam? You did that on the rational graph. When x approaches 0 from the right, so 0 from the right is going like this, right? You get very, very close to 0 from the right, not quite 0 though. Say, take the value x equals 0.001, you plug it in there. 1 over size of 0.0001 gives you a 10,000. My point is, the smaller the value for x, the larger is the cosecant values, right? So in conclusion, I can conclude that at x approaches 0 from the right, y approaches positive infinity. Like that. It's not my official graph. I'm just making a note, right? So I can graph later. We know that as x equals pi half, what size of pi half? You look at the unit circle, size of pi half is 1, right? Remember, psi is the y value. Psi pi half is 1. 1 divided by 1 is 1. So right there, that's 1. And x approaches pi from the left, right here. I'm going to mute Sade, I'm going to mute you, okay? As I approach is pi from the left, pi from the left. You know that pi is roughly 3.1415, etc. Right. Let's pick something smaller than 3.1415. Say 3.1410. Something smaller, right? You plug it in. You can use your calculator to do that. Make sure you calculate in radian mode. Again, it gives you something large. That's implied as x approaches pi from the left, y approaches positive infinity. Like that. And you keep doing that. You keep doing it. You keep going, approaches the point near the vertical asymptote, right? Say I'm going to approach is pi half from, pi from the right. So pi from the right, like that. Pi from the right. You pick something slightly larger than 3.1415, say 3.142, plug it in. You got a negative value. That's implied as x approaches pi from the right, y approaches negative infinity, like that. And we know that as psi of 3 pi half is -1, right? Psi 3 pi half is -1. 1 divided by -1 is -1. Therefore, you have that point right there. Later, we call that local minimum, but we'll talk about that later. And last but not least, we're going to consider what happened when it approaches 2 pi from the left. 2 pi from the left. Similar approach as x approaches 2 pi from the left, y approaches positive infinity, negative infinity, like that. So that's my rough graph. Now I put it together. Though you see in red, that's your secant graph. If you graph that on Decimal or on graphing calculator, if you have one, you don't see these dashed line because there's a vertical asymptote. But you're not supposed to see it there. I draw it there, so you know not to cross that. So that's the graph of cosecant function. Now, secant function is, we can rewrite it as 1/cosine x. Again, because you have a denominator. When you have a denominator, think vertical asymptote. Right? How do I do that? I'm going to set cosine of x equals 0 on your unit circle. What value of cosine of x give you 0? What value of x that give you cosine 0? Just from 0 to 2 pi though. What value of x when I plug it in? Pi over 2, good. Pi over 2. Yeah, and 3 pi over 2. Remember, cosine is x values. So that means my vertical asymptote is x equal pi half and x equal 3 pi half. When x equals 0, you plug it in. Cosine of 0 is 1. 1 divided by 1 is 1. So when x equals 0, it is 1. Say it again. Cosine of 0 is 1. You look at the unit circle. Here's 0. What is the length here? 1. Right? Cosine corresponds to axis. Just like you know that size of pi half is 0, is 1. Right? The side corresponding to y. If you doubt yourself, you can use your calculator. No, your regular calculator can do that for you. Make sure you put in radian mode. I suggest you practice on it for the sake of your exams. Knowing your way around the calculator helps you a lot. Again, you do the same thing. I would suggest you draw the vertical asymptote down. So I have pi half and 3 pi half. That's my two vertical asymptotes. What I'm going to do next, I'm going to assessing my point around those vertical asymptote point. Say if I approaches pi half from the left, let me tell you what's pi half equal. Pi half is roughly 1.570, etc. So if you want to pick something slightly smaller than that, say 1.568, right? You plug it in, use your calculator. You don't know what it is. I don't even know what it is because it's not unicircle. The point is, it gives you something positive. It gives you something positive, is large positive number. So that same argument, at x approaches pi half from the left, y approaches positive infinity. Positive or negative? Positive, okay. Pi half from the left is positive. Like that. At x approaches pi half from the right, same argument, pick something that's slightly bigger than 1.570, say 1.575, plug it in, negative number. That means at x approaches pi half from the right, y approaches negative infinity. It's very much the same thing I did before. What's cosine of pi equal? You look at the unit circle, what's cosine of pi? -1, right? -1. Right there is -1, 0. Right? So cosine is x value, so cosine pi is -1. 1 divided by -1 is -1. Two more to go. I want to know what happened when it approaches 3 pi half from the left. Can I skip that part? It's the same thing I've been saying. So I can read that. At x approaches pi half from the left, y approaches negative infinity. And x approaches 3 pi half from the right, y approaches positive infinity. Same argument. Right? Just do little step, one step at a time. Cosine of 2 pi is also 1. Right? 1 divided by 1 is 1. If you look at the cosecant graph, the very first one I did, you notice that the vertical asymptote of the cosecant graph happened to be the x-axis, happened to be on the x-intercept of the sine graph, right? So let's write that down. No. The vertical asymptote of the cosecant graph, the one in red, happen at the x-intercept of the psi function. The psi function is the one in dashed line. And it's always true. This is a very helpful little trick, right? So if you look at the cosecant and secant graph, are they similar? Yeah, they're very much similar. The only difference is what? What's the difference between the two? They look very similar, like a parabola facing away from each other. Look, they're very similar. I can extend another one more wing here. It's just, I don't need to because I'm not going out that way. They're very similar. The only difference is what? The position of the vertex. You guys shifted to the right a little bit for secant as opposed to cosecant, right? They're similar. Kind of like cosine and psi, they're similar. They just shifted in different positions. So here is a little bit summarized for the cosecant versus secant. They both have period of 2 pi. Who else have period of 2 pi? Sine, cosine, right? Sine, cosine. The vertical asymptote for the cosecant is all the x-intercept of the psi function. Say 0, pi, 3 pi, 2 pi, 4 pi, 5 pi, etc. Or you can go into a negative way, negative pi, negative 2 pi, negative 3 pi. In short, it's the multiple of pi. The local minima and then local maxima, here are the formula. I don't think you should memorize that. It's not, at least for now, not important. Don't cram too much in your head. If you look at the cosecant function, what is the domain of the cosecant function? It has multiple parts, right? It has multiple parts because of the vertical asymptote. So the domain is everything except where? Except at the vertical asymptote values, right? That's all you have to say. That's all you can say. Unless I give you a specific interval, say, give me the domain from here to here, then you give me the interval, right? But usually you just say everything but the multiple of pi. What about the range? Where does it start? Where does it end? Let's do the one below the x-axis. It starts from where? -1 to, I'm sorry, it starts from -infinity to -1, right? And then union from 1 to infinity. It is an odd function because it's corresponding to psi. For secant, it's a similar thing. It just shifted to pi half unit. So the vertical asymptote instead of 0 pi is gonna be start from pi half, right? 3 pi half, 5 pi half, 7 pi half, etc. Odd multiple of pi half. Local minima, local maxima. Oh, by the way, when I say local minima, local maxima for these two guys, I meant these. So here is a local minimum, because that's the bottom of that's a vertex. Right? Remember, open up, you have a minimum. So that's local minimum, local maximum, local minimum, local maximum. I know I say local maximum. How come local maximum is lower than local minimum? I'm talking about the graph. Right? I'm just considering about looking at just that U-shaped graph. That's considered local. That's why I say the word local. I'm not saying global. Right? I only care about around this neighbor. Same thing for secant. Local max, local min, local max, local min. All right, that's it for cosecant and secant. Let's take a look at the problem where it's more like your exam problem, more involved. As you know, if I give you something, you are supposed to give your function in this form. When I meant in this form, I mean you factor out the b value. Right? On the exam, we'll remind you about that. Okay. Or we even factor it out for you, but make sure you know how to do that. Say I give you the example. Say 2 cosecant. By the way, if you look at that function, it's 2 times cosecant. And then the one I put in blue parentheses, that's the input of cosecant. It's not multiplication. Okay. There is no multiplication between cosecant and 2 pi. So it's kind of like square root, right? Square root of 2. You can't just say square root, right? If you just say cosecant, this doesn't make any sense, right? You have to give me an input. Cosecant is say of x, cosecant of t, cosecant of theta, things like that. They already factor out the b, so that's good. This part right here, we did that last time, so I don't want to repeat myself. Again, you rewrite this. Let me give you a little tip. You rewrite it as cosecant is the reciprocal of what function? Cosine or sine or cosine? Sine, right? So you can rewrite it as this what? All you do is just put it over 1. Don't think too hard. Just put everything under 1. 1 over 2 sine. Change cosecant into sine. 2 pi x minus 1/6. Like that. I like to use little brackets just to distinguish from the parentheses. So what they do next is they assess in this one. The one is boring, it's just a constant. We did that last time. I showed you how to do that last time. Remember A is 2, amplitude, right? B is 2 pi. C over B, that's your phase shift, which is 1/6. Then the 5 key point, there's a formula for 5 key points. If you wonder where those problems come from, the first one, x1 is what? Equal C over B, which is, in this case, 1/6. They like to write it as 2/12. It's the same thing. And then you do x2, etc. So you can remember those. Now, so that's y equal 2 sine 2 pi of x minus 1/6. But it's not the one I want, right? The one I want is the cosecant, the reciprocal of that. The first x-intercept, if I was you, I would, should I plot the point down? Yes, I should. I should plot the point down. They tell you that this point is the x-intercept. The first one is the x-intercept. Remember what I said about x-intercept? It becomes what of the cosecant? X-intercept of psi is our vertical asymptotes, right? Remember the notes I put down earlier? So 2/12, that's the vertical asymptote. I'm going to put a little dash line here at 2/12. If you forgot, I wrote it back there right here. VAs of cosecant graph happen at the x-intercept of the psi function. What else? 8/12. 8/12 is the x-intercept of psi, so it's the vertical asymptote of cosine. And 14/12 as well. vertical, sorry, vertical asymptote, vertical asymptote, vertical asymptote. To make it consistent with the graph. Absolute maximum for the psi function. Absolute maximum. Psi function is the one in dash. Absolute maximum is, say, this point. Don't write anything down yet. For the psi function, it becomes what? Remember cosecant, it looked like this, right? You can grab it right now if you want. You know, it's just a bunch of parabola from that vertex point. The absolute global maximum or absolute maximum for the psi function becomes what? Become what? If you look at this graph, just this graph, is that the minimum point or the maximum point? Minimum point, so it's gonna be a local minimum, right? Local minimum. If you forget, that's what you do. Just look at the rounded neighbor. Is it the lowest point or the highest point? Local min. And this one, that blue dot right there, is local max, right? You guys get the idea? Let me use blue. Local max. Local means just around that region. I'm not talking about everybody. So far, I'm just telling you little pieces of cosecant and secant graph. So cosecant and secant graph look like a bunch of parabola, right? At least that's the minimum thing you remember for those two graphs. All right, let's take a look at tangent function. Usually when we given tangent x, we begin to write it as psi x divided by cosine x, right? Y over x. Here, the vertical asymptote, you set the denominator equal to 0. Basically, you set cosine x equals 0. They already wrote here. I don't have to rewrite that. Right here. Again, you look at the unit circle. If you forgot, draw it out. Which value of x cosine x equals 0? Here, right here, and here. Right? I'm talking about just like from 0 to 2 pi, right? So at pi half and 3 pi half, that's where cosine x is 0. So let me pi half. So let me draw vertical asymptote for the tangent. Similar argument like we did like we did in the first two. We're gonna assess in the value around those vertical asymptote always to determine the behavior of the graph. Right? So say if I want to know what happened around to the left of x of pi half, so I get closer and closer to pi half from the left. Right here. Similar argument, you pick something that's slightly smaller than pi half, use your calculator to compute what is pi half is. Plug into the tangent function. You have tangent function in your graph. Make sure your calculator is in radian mode. I see a positive number. That means it's implied at x approaches pi half from the left, y approaches positive infinity. Like that. What about pi half from the right? Similar approach, pi half from the right, y approaches negative infinity. let's do all the one around the vertical asymptote first. We'll talk about these little blue guys later. At x approaches 3 pi half from the left. I'm gonna skip the middle part here. It's just the same thing I've been talking about. Y approaches positive infinity. You can do 3 pi half from the right, but it's not necessary, right? We can just stop it right there because we're not graphing in anything more than that. What you can do if you want to. So far, so good. I'm just assessing the vertical asymptote, yes, and behavior. Oh, you can do negative pi half if you want. You can do more if you want. Yeah, but thank you. Yeah, maybe we can do more. Did they put? They don't have negative. Oh, they do have here. They do have it here. They do have it here. So negative pi half from the right is y approaches negative infinity. From the right, like that, negative infinity. All right, so those are behavior and the vertical asymptote. The next step is to determine the x-axis. I'm sorry, the x-intercepts. I keep saying x-axis. Now, if I give you some, don't write this down. If I give you, say, 3x over 5, and I ask you, y equal 3x over 5, and I ask you to find the x-intercept, what do? You said what equals 0? Y equals 0, right? So same thing we do here. Same thing we do in this problem. You have tangent is psi x over cosine x. Y equals psi x over cosine x. If I ask you to find the x-intercept, you said y equals 0, right? You don't have to write this down. Maybe you want, you can. Y equals 0, that's imply psi x over cosine x equals 0. Well, the bottom cannot be 0, right? But what? If the bottom cannot be 0, that function is 0 when psi x is 0. What value, if you look at the unit circle, what value of x psi x is 0? Here, right, is 0, pi, 2 pi, at least just from 0 to 2 pi. Right? So at x equals 0, tangent is 0. What else is 0? Where else is 0? At pi, right? So right here at pi 0. Or you can plug it in like this. I'll show you another way of doing this. Psi pi divided by cosine of pi. Right. And you plug in pi for x for pi for x. Psi pi is 0. What is cosine pi? What is cosine pi? 1 or negative 1? Negative 1, right? 0 divided by negative 1 is 0. That's why you have tangent pi is 0. You can do that way too. There's many ways to do this. What about these points in between? Let me denote in yellow. Say negative pi over 4, pi over 4, 3 pi over 4, 5 pi over 4. If you look at the unit circle, By the way, remind me to give you the unit circle so you can fill it out, okay? Just to practice. Pi over 4 is, say, this one right here. That angle right there, that's pi over 4. What is the x and y value at pi over 4? If you forgot, let me remind you, x is √2/2, y is also √2/2. Tangent is sine divided by cosine, but sine and cosine are the same. They both the same. So √2/2 divided by √2/2 is 1. So tangent is pi over 4 is 1. Let me move this one up a little bit like this. What tangent of negative pi over 4? Using symmetry. What tangent of negative pi over 4? If this is pi over 4, if this is tangent pi over 4, negative pi over 4, you go clockwise, right? You go down like that. So this become what? You have so for the x value, it's still positive because on the fourth quadrant, but the y values become negative. I know this is from the first lecture or something like that. This divided by this is -1, right? So at negative pi over 4, tangent negative pi over 4 is -1. 3 pi over 4. Again, you need to look at your unit circle. I know you don't have on top of your mind. That's okay. It's new. 3 pi over 4 right here, you plug it in. It turned out that the tangent is -1. And 5 pi over 4, do the same thing. You look on your unit circle, is 1. I have my vertical asymptote. I have my direction of my graph. I have those points that my graph going to go through. Just connect the dots and dot the vertical asymptote. By the way, I post my note right after class, always. Well, not always, but like 95% of the time or 99% of the time, right? So if you need to pull up something in the workshop, feel free to do so, okay? What is the period of the tangent function? The period of the tangent function is the distance between two consecutive vertical asymptotes. So all you have to do is look for the distance between the two dashed lines. Don't write this down. If I ask you the distance from between 3 and 5, what is the distance between 3 and 5? I know it's kind of dumb, but what is it? 2. How do you get 2? 5 minus 3, right? So if I ask you what's the distance between, I'll use something darker. Between the two, what do? Same thing, right? You take the second point, you take pi half, subtract negative pi half, right? Just like you take 5, subtract 3. So period is, if the tangent is a two consecutive vertical asymptote. Pick one, doesn't matter which one. Let me pick the first one. So I'm gonna take pi half, which is this point right here. Subtract negative pi half, subtract negative pi half, which is pi half plus pi half. Half plus a half is 1, right? And this is the period of a tangent, it's pi. You don't believe me? You can check, but the next one is give you pi as well. Objective 3B is your U try 1. Do the same thing I did here. On your U try 1, all you do is just pick the right graph. So here is the characteristic of tangent and cotangent. Kind of like cosecant and secant, they kind of similar, right? They just slightly different. The period for tangent, as we proved earlier, is pi. As same thing for cotangent, is also pi. The vertical asymptote is the odd multiple of pi half. If you look at the function, the domain for the tangent is everything but what? Odd multiple of pi half, right? Because those are vertical asymptotes. What about the range? Everything, right? The range, everything. Go from negative infinity to positive infinity. It's an odd function. Behavior is increasing. You don't have to know all those. It's just information. It's nice to read. It's nice to know more, but you're not supposed to remember all. Let's graph a tangent function. First, like I said, I know I say this already. I'm gonna keep saying it. You need to convert whatever the function into this form, meaning factor out b. I will briefly go through these steps, but I'm going to come back to it. A, which is your amplitude for the tangent, is used to find the y-coordinate of the point halfway between the x-intercept and the vertical asymptote. We'll talk about that later. We'll come back to that piece. The period, remember the period of tangent is pi, right? So the period is pi divided by b. And we talk about this. The period of a tangent is a distance between any two consecutive vertical asymptotes. Phase shift, let me use blue. I like blue. Phase shift is c over b. For the tangent function, phase shift is the x-intercept. And then the 3 key value, we'll come back to that. We'll come back to that. All right, let's do this. Given y equal tangent of 2x, I have a habit of putting a parenthesis like that. So that means it's not multiplication, right? It's the input of tangent. Find the period using the formula. Period using formula. Remember, period is pi over b. What is your b in this problem? Just 2. Just 2. So pi over 2. That's your period. The period. If you forgot, it's kind of like I asked you the slope, right? You don't say 2x, just 2, right? Find the period using the graph. Now they want you to eyeball the graph and tell them the period. Pick any two consecutive vertical asymptote, any at all. Let me pick between this one and this one, that one. To find that distance, I take the latter point, which is pi over 4, subtract the first point, which is negative pi over 4, pi over 4 plus pi over 4, a quarter plus a quarter is a half. And it should be matching your part A, whether you use formula or you use graph. Yes, question? Oh, it's okay, it's okay. Number 3 is your U try 2. We're going to do number 4 together because it's hard. I was thinking giving you 4 for you try 2, but it's hard. So I'll do 4. If you can do 4, 3 is easy. Hint for you try 2. Hint A is 1. You understand what that later. All right, number 4, they give you the graph and they want you to come up with an equation. First, find the period. So you know period is pi divided by b. Well, yes, the period pi by b, but I don't have an equation to look at, so I gotta look at the graph for the period, right? Which is the distance between the two consecutive vertical asymptotes. What that distance is, which is 1 minus 1, right? Or you can just eyeball it. What is this? 2, right? This is 1, this is 1. Distance is positive, it can be negative, right? 1, another one, so 2. Or 1 minus negative 1, 2. So that means, remember the period formula is pi over b. So I'm gonna let it equal to 2 for now, right? Period is 2. Find the phase shift. Phase shift is c over b. And then I'm stuck. I'm like, what the hell is C? Where do I get C from? Well, you cannot get C from the graph, but you go back to the explanation right there. The phase shift of the tangent function is the x-intercept within that period. Its phase shift is the x-intercept. If you eyeball the graph, where is the x-intercept? X-intercept. Not 0, right? No. X-intercept is right here and right here, right? I see 2 x-intercept. You can pick one. I'm gonna pick the positive 1/2. Is that okay? Oh, I'm sorry, guys. Hang on. Sorry about that. The picture is deceitful. Let me fix something. The period is not 1, 2. It's 1. There's a vertical asymptote here, but being masked by the y-axis. Sorry about that. I didn't, because I look at the second one. It's 1, right? I didn't see that. That's kind of very deceitful. So it's just here. So 1. Sorry about that. 1 is 1. So pi is 1. Phase shift is the x-intercept for that particular period. In this case, I picked from 0 to 1, so c over b equal 1/2. We have b, we have c, however, we don't have a. That's why I give you A here, and the number 3, you don't have to look for it. But now we have to look for A. Let me rewrite the original problem, the original formula. Y equal A tangent. B is, what is B? How do I find B? Yeah, you solve for the first one. You solve for that one, right? So B equal pi, right? Just multiply both sides by B. So B is pi. X minus C over B. I know B is pi, so I can plug it in here. So C over, let me use blue. C over pi equal 1/2. Solve for C. Cross multiply 2C equal pi implies C equal pi half. Oh, I don't need C. Oh, you know, I don't need that. I don't need that. I don't need that. I just need C over B. I don't need the individual. I don't need that. So minus 1/2. That's all. How do I find A? Well, they give you a little dot there. That means you have to find the coordinate of that point, right? And then plug it in for y and for x. And the only variable here to solve is A. Okay, so let's do that. I know y is 2, but what is x? Let's go back. Let's go back up here. Meaning of A. I say I'll go back to this piece. This right here. Meaning of A. This is used to find the y coordinate of the point halfway between the x-intercept and the vertical asymptote. Halfway between the x-intercept and the vertical asymptote. If this is 1/2, then the red point will be what? So let me zoom it out. Let me zoom it in a little bit. This is 1/2. This is 0. 1/2. So this distance right here between the blue one and the red one would be a quarter, right? Because this is 1/2, another 1/2, right? Halfway between the x-intercept and the vertical asymptote, so this is a quarter. A half plus a quarter will be 0.5 plus 0.25 is 0.75, right? Which is 3/4, right? 3/4. So that's right there is 3/4. So I have 3/4, comma 2. Red dot, that little dot right there. Plug it in, 2 for y. A don't know, tangent pi. X is 3/4 minus 1/2. Oh, sorry, 1/2 plus 4 is, yeah, 3/4. 2/4, 3/4. Double check, double check. What 3/4 minus 1/2? 3/4 minus 2/4 is 1/4. So 2 equal A. Tangent of pi times a quarter is pi/4. Tangent of pi/4 is 1, right? Tangent of pi/4 is 1. So A is 2. I try my best not to rush too rushy, but try to cover as much as I can. It's so long. Let's see. Let me give you try 3 right now before I forget. You try 3 is question 8. Yeah, the last one, the very last one. You try 3. I'm going to do number 5, which is very similar to number 8. Given this function, y equal 3 tangent 1/2 x minus pi 4, they want you to answer a bunch of questions. First, you need to rewrite it in the form that they want, meaning factor out the b, which they did it for us. Bullet point 1, the period is pi over b. From this one, you can get some information, right? B is, what is b in this problem? Half, and then c over b is pi half. Let me ask you a question. Hypothetically, if I have x plus, don't fix this. X plus pi half instead of x minus pi half, then what's c over b? Negative, right? Negative. Remember, the formula is, the negative is included in the formula. Just give you a heads up for number 8. So period is pi over b, which is pi over 1/2, which is 2 pi. Allow me to help you with the algebra, okay? If you don't think fast enough, it's okay. It's just algebra. You can do it at home later. The point is you understand like these process. Phase shift. C over b, which is pi half. There. We'll solve for, I think we have to solve for C later, but that's later. So we answer 2 of those. They want you to find the x-intercept and the equation of the asymptote. That's, you have to go back to the formula. Right up here, I say I go back. Right there, the one I did in blue curly bracket. In order to find the x-intercept and the vertical asymptote, you need to find these 3 keys values. The first one is your vertical asymptote, number 1. The second one is your x-intercept. And then the third one is the second vertical asymptote. Was vertical asymptote number 2. So bx1 minus c equal negative pi half. Bx1 minus c equal negative pi half. Let me give you the formula. I'll write out all the formula. Bx2 minus c equal 0. And then bx3 minus c equal positive pi half. You know what's b? B is 1/2. X1 is the one we're looking for. I need to solve for c using this, using the phase shift. C divided by 1/2 is the same thing as c times 2/1, 2c equal pi half. Multiply both sides by a half. C is pi over 4. That's just algebra. So minus pi over 4 equal negative pi half. You solve for x1. Let me give you the happy ending. Oh, I'll do it slowly. 1/2 x1 equal negative pi over 4. So you move the pi over 4 to the right. Negative half minus a quarter is a negative a quarter. Multiply both sides by 2, x equal negative pi half. And this point right here, the first point is your vertical asymptote number 1. The second point is your x-intercept. 1/2 x1 minus pi over 4 equals 0. Let me give you a happy ending. X1 equal, I'm sorry, x2 equal x2 equal pi half. That's your x-intercept. The last one, 1/2 x3 minus pi over 4 equals 0. X3 equal 3 pi half. And that's my second vertical asymptote. We almost there. There's one more piece we need to do, which is this one. But we do that after we plot these points. So I'm going to draw the vertical asymptote down first. So the first one is negative pi half. Negative pi half. The second one is 3 pi half. And that's my 1 period, right? That's the 1 period between the 2 consecutive vertical asymptotes. My x-intercept is pi half. How's you blue? I need 2 more points though, but we'll worry about that later. Actually, we should worry about that now. The last one is I need the coordinate halfway between the x-axis. I'm sorry, the x-intercept. I keep saying x-axis, and the vertical asymptote. Let's pick one. Anyone you like. You can either pick 0 or pi, right? The point that halfway between the x-intercept, which is in blue dot, and the vertical asymptote. Let's pick pi. It's fine. Let's pick pi. Let's pick this one. Plug it in. Let me use the original problem. Original problem state that y equal 3 times tangent 1/2 times x minus x. I'm going to rewrite it, just parentheses, minus pi over 4. You know what? Let me use this one. It's just easier. It doesn't matter, okay? I like to think that it's less computational for me. So the point halfway between the x-intercept and the vertical asymptote is this one. You can pick this one or this one, doesn't matter. Let's pick this one, 0. I like 0. 0. 1/2 times 0 is 0. So this is 3 tangent of negative pi over 4. What tangent of negative pi over 4, which is did earlier? Negative 1, right? Negative 1. So 3 times negative 1, which is negative 3. So at x equals 0, y is negative 3. Right there. Now you can do the same for this one, but I know that this is one of them. The other one is symmetric. It's instead of because tangent graph is what increasing graph, right? It's gonna be symmetric. Instead of -3, it's gonna be what? +3. Yeah. You don't have to do another calculation. Yay. You're done. I'm done. This problem very similar to number 8, which is your U try. Now, let me say something before I leave. First of all, I sent out an announcement this morning. You guys got that? All right, good. For the rest, I'm going to post the complete notes. Okay, I have the notes at home. I wrote it at home. I just don't have time to write it in class. I'll go to post the complete notes. Okay.